Hey, a new bit of gear on the bench here. Got myself a Advantest R6142 programmable DC voltage current generator. Nice bit of kit. They're not uncommon. If you can pick one up, if you find one cheap, definitely do so. They are a very nice bit of gear which you can use for calibrating your scopes and your multimeters and all that sort of stuff. Or if you just need an accurate DC voltage or current for your projects. This is the R6142, which is limited to a 10 volt range output, so maximum of 11.999 volts. There is another model, which I have here as well. This is one I've been trying to fix for a long time, been plugging away at it. It's a 6144. This is the big brother of this one. This one is good for 30 volts or 32 volts maximum output. So it is more desirable and goes for a lot more cash than this one. But to upgrade one of these, the R6142, into a R6144 is really, really easy. And it's free, and yeah, no recalibration required. It's simple to do. One caveat though, if you have the earlier, because I have another one, TR6142, this is the earlier version of these, the TR, it stands for Takeda Raiken. That's what Advantest used to be called before they were Advantest. They started in Akihabara many years ago, and they did make some good gear and became Advantest and still make very good gear. The TR6142 is all analog inside, and it can't be upgraded. There was never a TR6144 made. So yeah, if you got one of these, still a very good bit of kit. Lot more tweaking with your tongue in the right position with your little screwdriver inside to get these ones calibrated. But these can't be upgraded. The TR version cannot. The R version can. So this one literally just arrived. Like the guy just dropped it off like 5-10 minutes ago. So let's turn it on. I'll show you how to see what version you've got if the label is gone. And then we'll upgrade it to the TR6144, and I'll show you what the changes are there. So if I get the power cable, let's plug that in. Now, if I turn that on, I'll turn the lights off. There we go. R6142. That's telling us what it is, and it's version 2.04 in the ROM. And there we go. Ready for the output. So there's a switch on the back as well that you can turn it on and off. So it'll output or not output when you turn on. So if this switch is turned to on, I'll turn that light back on. If this switch is turned to on, if you turn this unit off with the output turned on, when you turn it back on again, the output will then again be on. If this is turned off, if the output is turned on and you turn this unit off and then back on again, it will have the output off. So basically this is like good for automation where you just want it to turn on and then be operating automatically. I usually leave it off so I don't go and blow up my circuits. So to upgrade this, it needs a bit of a calibration and that, and it's very cold because it's just come in from the truck. But the output does work. Make sure your output's working, because no point doing anything with a broken unit. We got to take the cover off, and there are 2 screws at the back to do so, and then the whole thing just slides off. I'm hoping I can use this as a reference to fix the faulty one that I've got. That's the idea, and so I have one that's working. Now there's a couple of jumpers we have to close. So I'm going to zoom in because there is one jumper right here. So that's about the center there. All right, there it is. You see that cut jumper? That tells the processor board what model it is. So what we've got to do is we've got to close that and solder it. So if we put a solder blob on there, I'll just fire up the soldering iron and align these little loops. So if we just blob that up, that one is good. So now this top board thinks it's an R6144. There is one more thing we have to do. If we flip it over, because now we've got to tell the output board that it's a 6144 and enable the high voltage that the processor board will be telling it to output. So if we zoom in again, here, right there, there's another one, right in the middle there. And then the last one is just up right there, JP11. So if we put a blob there, we are done. I believe one of these is for the voltage and one's for current, to unlock the higher current and higher voltage. So we got jumper 2 closed, jumper 11 closed, and of course the first one, jumper 1 closed. This is now an R6144. Of course it still says 6142, but whatever. Let's throw the cover on, see what happens. Alright, now let's see what it says. Booting 6144, we are done. Fantastic. Alright, let's give this thing a bit of a test, see what happens. So it's going to be hard to show both screens at once because of the angles and stuff. So I'll read out what I'm sitting on here, and then you can watch what's going on here. Using the old Fluke insulation multimeter, but this thing has always been completely spot on when it's been calibrated. What was the last calibration date? October 2013. So basically, yeah, 9 years ago, something like that. But that's alright. Fantastic piece of kit, and it's never been a problem. That's what you get when you pay for Fluke. So let's plug that in. Just some banana leads from the output directly into the multimeter. Let's turn that to DC volts and turn the output on. We're in the correct range. Yep, so I've got 0 and I'm reading 0 on here. So let's go up. What's 1 volt say? Yeah, that's pretty much spot on. 5 volts. Yep. 10 volts. Pretty good. 15 volts. 20 volts. Still looking good. 25 volts. Yeah. 30 volts. Still fine. 32 volts. Perfect. Not a problem at all. We've unlocked the voltage successfully and it's looking good. So let me turn that all the way back down again, and I'll pull these leads out because we'll check the current output now. So let's turn this onto milliamps and then the highest range. Okay, and I've got this one here. I'm just going to use a 100 ohm load. It's just a bunch of 1k resistors. I think they're 1k resistors. All in parallel to make it 100 ohms. I measured 100.113 on the 4-wire mode on my 6.5 digit multimeter. Doesn't matter though, because we just need a load to get our current. So, not in there. We've got to turn that to milliamps. Blue button to put on DC, and then on those two. This is good for 440 milliamps. It's not designed for measuring high current. It's a insulation multimeter, so it kicks out 1000 volts over here. Yeah, but 440 milliamps is more than what we need. So let's see what it says. So 10 milliamps. Output on. Now I've got 10 milliamps. A little bit low. Might need a calibration. 50 milliamps. Yeah. 100 milliamps. Nearly there, but yeah. Now this is a maximum 120 milliamps that the R6142 can put out. So we should be able to go up higher. 130, 140, 150 and 160. That's maximum. So yeah, this will need a bit of a adjustment on the current output. That's to be expected. I don't know what the history of this is. It could have been, last calibrated, decades ago. Who knows? But that's not a problem because the service manual has the full procedure. So that is looking good. We got a thumbs up for voltage and a thumbs up for current. Fantastic. Now there is one more thing we should look at while you're inside. It's probably a good idea. And I'll get this thing open again. This is what you want to check while you got the unit open. It's the RAM backup battery. This is a RAM chip here. We got the UV erasable EEPROM for the firmware. We got a GPIB controller chip, and then the main CPU. So this battery backs up the RAM. The RAM holds your calibration constants. If the battery fails, you lose your calibration constants or your calibration settings. And also the RAM holds the front panel settings and whatnot, so that you can, when you turn the unit back on, it comes back with the original settings that you left it with, and you can continue using it as you were before. So that's I believe it's a lithium thionyl chloride, a very common battery used for battery backup for RAM, and it's a 3.6 volt battery. If you want to replace that and you don't have the means to recalibrate the unit, it's probably a good idea to get 2 AA batteries in a battery holder and then solder it, follow the traces around and find a convenient place to solder it on. And then you can, keep that 3 volts there, remove the battery, put the new battery in, and then remove those 2 AA batteries in the battery pack, and then you're good. I show that process in another video with a Tektronix scope. So check back in my video history, and you'll find one of the Tektronix scopes, 2467, I think it might have been, where I play with that and I do the same process. But if you have a 6.5 digit multimeter and a couple of precision resistors as defined in the service manual, which you'll find linked down below, you can recalibrate it quite easily. You don't need to twiddle any dials or like trim pots and hold your tongue in the right position. It's all done from the front panel and it's all digital, so you just put into the calibration mode with a switch on the back, and you run through the calibration, and you just it says I'm putting out 10 volts. You measure it and you say no, you're actually putting out 10.1 volts, and then it goes okay, and it corrects for that, and then goes to the next version or the next voltage, so on and so forth, and it just tells you what it thinks it's putting out. You tell it what it's actually putting out, and it then makes a correction table in the RAM. So it's very easy. There is one dial which is underneath, you might see if you open it up. One little trim pot here. Don't touch it. The service manual and the user manual don't make any mention of this. There are no schematics for this unit that were released from Advantest. So it doesn't say about this. It doesn't say to touch it or adjust it. I've scoured the service manual trying to find any information on this. Just leave it alone. If this is anything like, or if this part of the circuit is anything like the TR, the early version, the TR6142, which I was showing before, it may be to do with the if there's a push-pull amplifier, it just balances that push-pull amplifier, so it's not one way or the other, like not biased one way or the other. But I'm not sure, so don't touch it. The TR6142, it doesn't say much about the same pot, or what I assume is the same pot, but I have found that the way you can adjust that is just calibrate your zero, calibrate your high range, and then set it to the middle, and then dial that until the middle is actually the middle, and it seems to be pretty good. But yeah, in this unit, don't touch it. So that's done. We're good. We got the 6142 converted to 6144. We know how to change the battery. It's all fantastic. So I hope you found that interesting, somewhat informative, and I wish you luck as you go forth and upgrade your units. We'll see you in the next one.